Our solar system is a wondrous place with a single star, our sun, and everything that orbits around it: planets, moons, asteroids, and comets. What do we know about this beautiful solar system we call home? It's part of an even larger cosmos with billions of other solar systems.
Hi, I'm Jim Green, NASA's chief scientist, and this is Gravity Assist. With me is Dr. Steve Squyres from Cornell University, and we're talking about the incredible rovers, Spirit and Opportunity. And they've really transformed our knowledge of Mars, that beautiful red planet you can even see on a beautifully clear night on the right place on this planet. As we know, the twin rovers, Spirit and Opportunity, were launched in 2003 to explore Mars and search the areas for all sorts of stuff, and perhaps even find signs of life. But for those who may not be familiar with their story, Steve, tell us a little bit of background on how Spirit and Opportunity came together.
Oh, my goodness. Well, our mission kind of arose from catastrophe. There were the two Mars missions that flew in 1998. Launched in 1998 that were unsuccessful. And so NASA was looking for a way to recover from that and regain momentum in the Mars program. And what happened was we had already built a set of instruments. We had a suite of instruments ready to do science on Mars, but no way to get them there. But then we sort of remembered Mars Pathfinder. Mars Pathfinder was this magnificent mission back in the 90s that demonstrated and validated two key technologies. One was airbags for landing, and the other one is it had that beautiful little Sojourner rover, the tiny thing about the size of a microwave oven, but it showed that you could actually drive around on Mars. So what we did with Spirit and Opportunity was we blended those two technologies together, scaled up the rover massively, put the science payload onto it, and we were off and running. And we got selected for flight by NASA in the summer of 2000, when we were on top of the rockets in Florida 34 months later.
Wow. Well, those two rovers, their nominal mission was 90 days.
90 Martian days, yes.
90 Martian days. So you already know going in that, after a successful landing, and Mars is hard, we all know how hard it is to get to the surface. After that successful landing, everybody had to be on it and working, full tilt to be able to really milk out everything they could in the 90 days. But then something happened.
Yeah, a lot happened.
What was it?
Well, okay, so you got to realize 90 days was when the warranty expired. None of us expected the wheels to fall off when the sun came up on the 91st day.
Sure,
okay?
Sure.
But why did they last so long? There are really three reasons. One is we built good hardware. And Jim, if you want to accuse us of over-engineering, I'll plead guilty as charged at this point.
Well,
okay?
I'm glad we did that. I can't be happier.
Okay. The second thing was we got lucky with the weather. One of the things that we thought was going to kill these vehicles was going to be buildup of dust on the solar arrays. Mars has this very fine-grained dust, like cigarette smoke sized in the Martian atmosphere. It settles out onto solar arrays. And what had been seen on previous missions was just that they just build up dust continuously. What we have experienced with both of our rovers, we call them cleaning events, but they're gusts of wind that clean the dust off the solar arrays. In fact, we just had a gigantic one for Opportunity very recently. These have cleaned the solar arrays off over and over, and each time it happens, it gives us a new lease on life. The third thing is that we discovered a trick, a very simple trick. We have no way to articulate the solar arrays. We can't tilt them up and down. We don't have motors that do that. Mars has seasons: winter, spring, summer, fall, just like Earth. And in the winter on Mars, the sun, we're in the southern hemisphere, the sun goes low in the northern sky. What we wish you could do is tilt the solar arrays to the north and get more sun. What we do instead is we simply drive the vehicle onto north-facing slopes. That tilts the entire vehicle towards the sun, and it boosts our power. And by operating only on north-facing slopes, in the wintertime, we've been able to survive multiple winters on Mars. So those are the three main reasons why the thing has gone on so long.
Right. So you winter over, but you're at a place that you can actually do some science.
Yeah, well, in fact, there have been winters when we've managed to stay busy exploring all winter long. If you can, so we spent the first winter with Spirit on the northern flank of a mountain, and everywhere you went was tilted north. So we were able to operate all winter long.
Really great. Well, another thing that's really spectacular about these two rovers is some of the things that they found. What are some of the surprises?
Oh, man. It's a long list at this point. I'll give you a couple of favorites.
Thank you.
Very quickly, with opportunity, right after we landed, we found these little weird spherical things. We called them blueberries because they were embedded in the rock like blueberries in a muffin. And what we learned over time was that these things are what geologists call concretions. They're made of hematite, that's an iron oxide. And what happens, the way concretions form on Earth is typically you have rock that is saturated with liquid water, and there's some mineral in it that's super saturated and wants to precipitate out, and it does, and it finds a little nucleation point, and then it grows, kind of adding layer upon layer and building a little hard spherical nodule like the way an oyster builds a pearl. So this was clear evidence that the ground here had just been soaked with liquid water in the past.
Yeah, in fact, you probably, let me just see how this might have gone. You said, okay, these look like blueberries. They're about that same size, but you didn't know what they were.
We had no idea. We had no clue. Yeah,
but you had the tools to be able to figure it out.
Yeah, that's right. That was the thing. It was interesting trying to design these rovers, because when we tried to design them at the outset, I always describe the rover as being like a Swiss Army knife. You give it as many different blades, as many different tools as you can, but you don't know what you're going to find when you get there. So you try to endow the vehicle with as much flexibility as possible, but then once you get to Mars, you got to use the tools you brought with you. And fortunately for the blueberry question, we had the tools we needed.
To me, when that came out, that was just a sea change in my thinking. Mars today, that desolate planet. I could never imagine it being swimming in water, and yet you find evidence from the mineralogy and everything around you that there was water in these areas for long periods of time.
And it's been so many years now. It's been 14 years. It's hard to even remember back to the Mars that we thought we knew in 2003, because it was just this dry, dusty, rocky, desolate place that there had not been, nobody had even sampled bedrock yet by the time we got there. And so to have this compelling evidence in the minerals and the chemistry for water just laid out for us like that. Now, again, as you said, if we didn't have the right tools, we wouldn't have been able to read the story, but the story was there to be read.
So what are some of the other things that you really discovered that you enjoyed?
Another one was the silica that Spirit found. That was crazy. So we were driving through this little valley with the Spirit rover, and this was late in Spirit's mission when the right front wheel, you remember the right front wheel had failed, so it wouldn't turn. And so to drive, we had to drag that dead wheel through the soil, and we kind of dug a trench. And one day after one of these drives, we were in this little valley, which we later came to call Silica Valley, by the way.
Sure.
We dredged up some soil that turned out to be as bright as white snow. This caught our attention. We went over and we measured its composition. It was not snow at all. This stuff was more than 90% pure silica, SiO2. Wow. This is not quartz. It's not crystalline. This is not beach sand. It's hydrated. It's opal.
So what does that tell you about that ancient environment?
What that tells you is that there was some kind of hydrothermal activity here. Either there was caustic steam coming out of the ground and leaching some elements away and leaving behind enriched silica deposits. That happens around some volcanic fumaroles on Earth. Or it was a place where there were hot springs, hot water bubbling out of the ground and precipitating out silica. The thing about fumaroles and hot springs, both of those, is that when you go to those on Earth, they are teeming with microbial life. Now, I don't know if there was microbial life, but this was a habitable place, and that silica discovery in Silica Valley showed this.
That was pretty spectacular.
So that's one of my favorite Spirit discoveries.
Well, Spirit was doing so well, and then it ran into a problem. What happened?
Well, I always felt like there were two honorable ways for the mission to end. One would be if Mars just reached out and killed us, okay? If there's a major dust storm, if there was some event that killed a rover. The other would be if we wore it out, just flat out wore the thing out. And it was a combination of those two that killed Spirit. When we lost the first wheel, we lost the right front wheel. That made it very difficult to drive. We had to drag that dead wheel. We could still move. We were driving around and we were doing kind of okay. We weren't a speedy vehicle by any means, but we could move. Then what happened was we lost another wheel. We lost the right rear wheel. We just plain wore the thing out. The goal was to milk it for all it was worth, and we did. Once we had lost 2 wheels, the vehicle could no longer drive. It was a stationary vehicle, and when we lost the second wheel, we were on flat ground. Because we were on flat ground, we could no longer do that trick of tilting towards the sun, right? We couldn't get through the winter by driving onto a steep slope because we couldn't move anymore. And
so was there some place, it was a race to get to some place where you could get that?
We were trying to get to a place where we could do that, but then when we lost the second wheel, we were done. Okay, it's a very good rover. It's not a real good lander. Okay, it's not. Sure. It was never designed to be stationary. And so once we lost the ability to move, we knew that it was inevitable that final winter was going to kill the vehicle, and it did.
So how did you feel about that?
You know, it was funny. I felt okay about it. I didn't know how I was going to feel, but I felt okay about it for 2 reasons. One was that, as I say, it was an honorable death. The vehicle lasted far longer than we expected, and the reasons that we lost it were, I thought, fine. Okay, we wore the thing out, then Mars reached out and killed the vehicle, and there was nothing we could do. Okay, so that's one reason it was okay. The other reason it was okay was we had kind of an Irish wake. We got together and drank a few beers and told a few stories.
Okay.
And then the next day we went back to work operating Opportunity. So that softened the blow quite a bit.
Sure, because you still had,
we still had and still have Opportunity.
Yeah, right, and it's going fantastic. One of the things that I think Opportunity has done, not only some of the great science, some of which you've already mentioned, but the vistas.
Oh yeah.
Rolling up to Victoria Crater just absolutely blew me away.
Yeah, we've had several of those. When we first got to the one that we called Endurance Crater, that was the first big crater that we peered down into. And boy, I'll tell you what, that day that we pulled up to the rim of that thing, and we were right at the rim, none of us had ever seen anything like that in our lives. It was just, everybody, we just stopped. We just stopped and stared like, it was like coming up to the edge of the Grand Canyon if you've never seen it, Right. Same thing happened to us at Victoria Crater. Endeavor Crater was a little bit different. Endeavor is the big one that we're at right now. And we had a long, like a 16-kilometer drive. It took us 3 years to get to that thing. And the thing that's different about Endeavor, which is where we are now, is that it's got this big, tall rim. And so we were driving across these flat, featureless plains, and we could see the crater rim on the horizon, kilometers away. And it was like being on a ship at sea, and you could see land. Mm-hmm. And we're trying to get to land, and we finally got there. And the beauty of that one was the rim of Endeavor Crater, where we are now, is so different from the rest of the Opportunity landing site that as soon as we pulled up onto that rim, it was like a new landing site. It was like a whole bunch of new science questions. It was like the mission started over again.
So as you're racing to Endeavor, are you also seeing the ejecta field that's all over the ground, or is that blown away?
No, we didn't. It's been buried. It's been buried. The rocks that we were driving on top of are younger than Endeavor Crater itself, and so the ejecta have all been buried by the rocks that So it really was like an island. It was like an island sticking up through a sea of these sedimentary rocks.
But you're finding some fantastic stuff.
Yeah,
in those rims.
Yeah, and there was some stuff that popped at us right away. So like the minute we sort of pulled onto the rim of Endeavor Crater, we started seeing all these white stripes on the ground. I mean, it literally looked like somebody had gone out there with a paint with a can of white paint and a brush about half an inch or an inch wide, and it just painted stripes on the ground.
Yeah, straight lines.
Yeah, it was crazy. And those turned out to be veins of calcium sulfate, veins of gypsum. Which is a mineral. It's a salt that precipitates from liquid water, and this is a place where water had gushed through fractures in the ground. Another thing that we discovered was we found clay deposits. We found the first clay deposits that were observed on the surface of Mars. And one of the things about clays is that, in contrast to some of these other minerals, which typically a lot of them require fairly acidic, low pH kinds of conditions to form. You can only form clays when you have kind of neutral or maybe even a little bit alkaline pH. And so the clays in particular pointed to water with a chemistry that would have been more suitable for habitability.
The astrobiologists love clays
Yeah.
too, and I listen to them talk and get excited about these things. And that's because, with clays forming in water, that's also a great place to be able to build complex carbon molecules. And, maybe a place where life got a jump start.
Yeah, so the clay deposits on the rim of Endeavour were particularly important for us. And then right now, as we speak, Opportunity is driving down a little gully. Looks like it was carved by a flowing fluid, water, debris flow, something like that. These things have been seen from orbit on Mars for decades, but we're the first to actually get into one and explore one. We call it Perseverance Valley because it took so long to get there.
How does the team come up with these names? You just have the ability to do that, or?
Yeah, the naming is both necessary and fun. We discovered very quickly that it's necessary. I remember some of our early rover tests. We'd start off with Rock 1, Rock 2, Rock 3, and that gets old real fast.
That sounds boring to me.
That doesn't work. So then once we got to Mars, we started assigning kind of random names to things. It looked like this or it looked like that. But then I remember when we finally figured out naming. It was our first Thanksgiving. It was our first Thanksgiving on Mars. And we wanted to give the whole team 4 days off, but we wanted to keep the rovers busy. So the Spirit rover, we kept busy for 4 solid days, taking this gorgeous 360-degree panorama. We called it the Thanksgiving pan. We come back from Thanksgiving and people start naming rocks, and they start naming them cranberry and drumstick and mashed potatoes and that sort of stuff. Ha ha, funny. But
it stuck.
But there's more to it than that.
Oh.
What happened was, then you drive on and the mission continues, and you get 8 months down the road, 2 years down the road, and somebody shows you a rock called cranberry sauce. And you go, cranberry sauce, Thanksgiving. Oh yeah, I remember where that was.
Ooh,
that was the key. And so what we discovered was that if you have a set of names that have a theme that connects them, and it's somehow connected in space or in time to a particular place and a particular time that it's happening, it provides a really valuable little tool to help you remember where a particular rock was. Okay, so if I see the rock Cherry Bomb, I remember Cherry Bomb, 4th of July. It's a kind of fireworks.
Yeah.
I remember where we were, 4th of July, summit of Husband Hill, and so it's a very useful little trick.
That sounds really neat. What do you think Opportunity has yet to learn about Mars?
I don't know. That's the fun part. If I knew, you wouldn't have to keep paying for it, Jim.
Yeah, fairly so. But no. It's seeing some beautiful stuff. You've started to check out a number of things.
Yeah. There are a couple big things on our hit parade at this point. We really, really want to absolutely nail down the formation process for Perseverance Valley. Especially, we're still only partway down this thing. We're going down it from top to bottom. We're only maybe a third of the way down. We think that the most important clues of how it formed are going to be towards the bottom, where the deposits of the erosion are actually going to be. So we're really excited about that. Another thing that's really important to us is that we think we may have already once found, and we hope to find more of them, rocks that are older than the Endeavour crater event itself.
Wow.
Because those would be the oldest rocks ever seen by any Mars rover, and so they give us a deeper glimpse further into the past than anything else. So that's another thing that we're going to be searching for in the months and years ahead.
Were these rocks uncovered in the impact, or?
What happens is the impact will kind of jumble and jostle rocks around, okay, and some things will be kind of shoved upwards relative to others, and you may lift some of them up to the point where you'd be able to see them.
Oh, that sounds fantastic. Spirit and Opportunity, their mobility has really changed the way we think about our solar system in the area of exploration and what we can do. There's all sorts of new ideas about how to be able to maneuver on the surface, or balloons, or, aerial vehicles of some sort. And Mars with an atmosphere gives us that opportunity to explore those different dimensions.
Yeah, it's mobility, however you achieve it, is incredibly important. The way I always looked at it, imagine you're a geologist, and you get sent to some fantastic new place that nobody's ever explored before, and you get set down and you're told to get to work, but we're going to nail your boots to the ground.
That wouldn't be good.
So yeah, it's good to be able to move around.
Yeah, it really is. But InSight that's coming up is a lander, and it's designed to be able to deploy instruments and and those instruments need to stay put.
Well, InSight is a geophysical station.
Right.
Okay, and when we have geophysical stations on Earth, we put them in place. So, I mean, for InSight science, it makes sense.
That's right. So now we have all kinds of tools like that in our tool bag. And indeed, the next big rover that we're building is Mars 2020. What do you think Mars 2020 is going to find?
Well, the thing that intrigues me about 2020 is that its primary job is to collect and cache a suite of samples to come back to Earth. I'm a huge fan of sample return. The thing about sample return missions, you can, instead of using instruments that have been miniaturized and toughened so that you can fly them into space and launch them and land them, you can use state-of-the-art laboratory equipment. Samples are a gift that keeps on giving. I mean, the best science ever done with the Apollo samples that were collected in the late 60s and early 70s is being done today by scientists who were not born when those samples came back, using instrumentation no one had ever dreamed of at the time. So because Mars 2020 is the initiation of this Mars sample return process, and it's going to take a while before we can get those samples and bring them back to Earth. But that to me is the exciting thing about 2020 is what we're going to find in those samples when we get them.
Yeah, indeed. Right now we've got 3 big sites, and one of them we are actually pretty familiar with.
Yes, one of them is Gusev Crater, and I think part of the reason for that is those silica deposits I was talking about.
Yeah, pretty exciting. An environment that perhaps in the past had an opportunity for life to get started. You know, Steve, all my guests have to answer this question because it's really so important for us to remember how we got into this field. You know, what was that event that occurred, perhaps several events, that gave you that gravity assist that allowed you to get propelled forward and become the scientist you are today?
For me, there were 2, very clearly. The first one was my 3rd year as an undergraduate student at Cornell University. I was a geology major, and I was still looking for the thing that I wanted to do. And I signed up for a course that was being taught by a professor named Joe Vaverka, this was 1977, on the results of the Viking mission to Mars, which was flying at the time. It was a graduate level course. I was the only undergraduate level in the course, only undergraduate in the course. In fact, he almost kicked me out at the start of class. Because it was an undergraduate course, we were expected to do some piece of, or a graduate course, we were expected to do some piece of original research. So a few weeks in the semester, I thought, all right, I'm going to go to the Mars room. This is before CD-ROMs, this is before internet, where they keep all the prints, all the photographs of the Viking pictures, and flip through them for 15 or 20 minutes and see if I can come up with an idea for a term paper. Got a key to the room, went in there. It was just this big kind of warehouse-like place with cardboard boxes full of these pictures that nobody had seen, basically, at that point.
Wow.
I walked out of that room 4 hours later knowing exactly what I wanted to do with the rest of my life. You know, I didn't understand what I was seeing in the pictures, but that was the beauty of it. Nobody did. It was scientifically, it was a blank canvas. And that lure of exploration, that lure of the unknown, was just irresistible to me. The second event for me was I was incredibly fortunate. I was asked by Carl Sagan and then was sort of mentored by both Carl Sagan and Joe Vaverka, but I was asked to participate in the Voyager mission to Jupiter and Saturn. And so I was part of, a little junior baby grad student part of the science team for the Voyager flybys of Jupiter and Saturn. And the Voyager 1 flyby of Jupiter was absolutely the formative event of my career. After that, I was utterly convinced what I wanted to do was flight projects. In the space of 48 hours, the moons of Jupiter, the whole Jupiter system, went from these little points of light that you could observe through a telescope to whole worlds that we could map. And I just became a complete flight project junkie. I mean, I decided that after that experience, I was willing to put up with 20 years of sitting on airplanes and drinking bad coffee and looking at PowerPoint slides just for another 48 hours like I had at Voyager and at Jupiter. And so, yeah, those 2 events crystallized for me what I wanted out of my career.
I really appreciate having the time to talk with you today.
Enjoyed it.
I'm Jim Green, and this is your Gravity Assist.